Hello, my name is Keshwani. That's Keshwani, Keshwani. We're here because we want to learn algebra. Today is our lesson number 32. The problem is already on the blackboard, day number 32. It's already on the blackboard. We are doing right now adding and subtracting of like terms, which is what we're going to do, which we have been doing from day number 21 through 40. Today is our day number 32. We're given three expressions. And our job is to add those expressions. 3x squared plus 3y squared minus 4xy, 3xy minus 5x squared minus 7y squared, 5y squared plus 4x squared minus 5xy. Our job is to add these three expressions. And in order for us to be able to add these three expressions, we have to make sure that we line up the like terms properly. So let's get going then. 3x squared first, then the xy, that's the addition. X squared, then the xy, and then y by itself. So we have negative 4xy plus 3y squared. And now we have to make sure we line up the same thing in the second expressions. So we have positive 3xy minus 5x squared, negative 7y squared. And then we have 5y squared, positive 5y squared, 4x squared, and negative 5x squared. Negative 5x, that's it. Now that they are all lined up properly, all the like terms are lined up properly, all we have to do is simply add their coefficient. So here we have 3x squared with a positive sign in front of it right here. Then we have negative 5x squared from there, and then we have positive 4x squared from here. So plus 3 plus 4 is plus 7, minus 5 is going to be plus 2x squared. And then we have negative 4 and negative 5 will make it negative 9, plus 3 will give us negative 6. And then here we have positive 3 and positive 5, that's positive 8, minus a 7 is going to give us positive 1. But one does not write it as 1 squared. If there is no coefficient in front of it, it is understood that there is only one of it. It's understood there is only one of it. If I just write a, that means there is only one a. Because had there been 11a, I would have put 11a there. So if there is no coefficient, in front of the variable, it's understood that there is only one of it. So that's it. That's your answer. 2x squared minus 6xy plus y squared. Let's do one more, shall we? Number 32. Oh, sorry. No, number 2 is what I meant to say. Here is the problem. I don't know why I'm holding the red marker in my hand. We have 4a squared minus 7b squared plus 5ab. Then we have 5b squared minus 7a squared minus 4ab. Then we have negative 2a squared plus 7ab plus 5b squared. And we are asked to find the sum of these three expressions. Again, these three expressions, the way they are written, they cannot be added up because like terms are not lined up. You cannot add a squared to b squared. So let's line them up properly. So we have 4a squared plus 5ab minus 7b squared. Then we have 5b squared, positive 5b squared, negative 7a squared, negative 4ab, negative 2a squared, positive 7ab, and positive 5b squared. Let's add them up. See what we get. So here we have a positive sign in front of it right here, and so does this guy. Positive 4, negative 7 and negative 2 is negative 9. Negative 9 and a positive 4 is going to give us negative 5. Negative 5a squared. Then we have positive 5 and a positive 7, there's positive 12. Positive 12 and a negative 4 is going to be positive 8. And then we have positive 5 and a positive 5 is positive 10. And a negative 7 is going to give us positive 3. Positive 3b squared. 5a squared plus 8ab plus 3b squared. Want to do one more? Yes? Let's do one more then, shall we? Let's do one more. P cubed plus 3p minus 2p squared, 4p squared minus 3p cubed minus 5p, 5p cubed minus 6p squared plus 7p. Find the sum of these three expressions. Again, they cannot be added the way they are written. In order for us to line up the like terms properly, we have to line up all the p cubed together, then the p squared, and then the p, in the descending order of the power. In the descending order of the power. Not the ascending order. Descending order means going down. I do not know why I have this uncontrollable urge right now to look up how to spell descending, which is exactly what we're going to do. It's a very simple word for a native speaker. And I do not mean to shock anybody who is watching this video, but I do not qualify as one of them, as a native speaker. So I have to look up the spelling of the simplest word just to make sure that I do not make a boo-boo. Descending. The rule in algebra, in the language of algebra, is that if you have an expression with various powers, then the expression has to be written either in the ascending order of the power of the given variable or descending order, either increasing order or decreasing order. But it is preferred to write them in a descending order. So you have a to the fourth, you put that first, then the a cubed, then the a squared, and then the a. And then finally the coefficient by itself, if there is any. You could do the other way around, but it's preferred to do it in descending order, as opposed to ascending order, which only God knows how to spell. As a matter of fact, even though these are very simple words, I'm going to actually put them in my list there of the vocabulary so that we can learn them properly along with their spelling. Oh, what do you know? We learned something new. The only difference between ascending and descending is the prefix there, d as in not, and you take out the a because you're not going to have two vowels together. So d as in not ascending. Ascending and descending is the same spelling with just the prefix d in the front of it. You take out the a because, as I said, you're going to end up with two vowels together otherwise. I'm going to actually make a note of them after the video is over, and we're going to cover them in our vocabulary videos. For those of you who do not know what I'm talking about, in addition to my videos that you're watching right now on algebra, I also have videos on geometry. And if you want to watch those, just type in Kashwani Prep -geometry -day 32. Just spell out the word geometry -day 32, and you will see what I did on day 32 of geometry. And similarly, I have vocabulary videos. If you want to improve your vocabulary, particularly if you're planning in the near future to sit for the SAT, GRE, or GMAT, or TOEFL, the key ingredient, the most important part of getting a decent score in the English portion of the exam is having a decent vocabulary. And this is what I do. I tutor for those tests, and therefore I have made some videos on vocabulary as well, which is why you see me having these urges to look up the words and learn the spelling and the meaning and so forth. So I'm going to cover these two words in the future. Anyway, enough said. Let's line them up. So p cubed, as I said, in the descending order. First the p cubed, then the p squared, minus 2p squared, then the 3p. Same thing here. Negative 3p cubed, negative 3p cubed. They're not lining up properly, and I don't like the way the looks of it. Negative 3p cubed right here, plus positive 4 squared, p squared, and then negative 5p. positive 5p cubed, negative 6p squared, positive 7p. Now that all the letters, all the variables are arranged in the proper order, in the descending order of the exponent, now all you have to do is simply add up their coefficient, because now they're all like terms. This is p cubed, this is p cubed, this is p cubed. All we have to tell is, all we are asked is, how many are there? How many p cubed are there? So there is 1 over here, positive 1 and positive 5 is positive 6, minus 3 is negative 3p cubed. Then we have a negative 2 and a negative 6, which is negative 8. Negative 8 and a positive 4 is negative 4. Negative 4p squared. And then finally we have positive 3 and positive 7, which is positive 10. Positive 10 and a negative 5 is a positive 5. There you go, that's your answer. Why do I have a negative here and not in my notes? This is wrong. This is not negative. This is positive 3. Positive 1 and a positive 5 is a positive 6. Positive 6 and a negative 3 is positive 3. Positive 3p cubed, negative 4p squared, and positive 5p. Now the answer matches with what I have in my notes. That was it for today. I will see you tomorrow on day number 33. We'll keep chugging along, little by little every day, a few minutes every day, and if you continue with it in a strict sequence from day 1 through until I finish, which might be the day 100 by the time we finish the linear equations and the word problems. If you continue working with me, and you make sure that, and if you do every single problem that I'm doing on the blackboard, I guarantee you that you will improve your algebraic skill. The language of algebra, the fear that most people have of dealing with word problem and solving algebraic problem will all be gone. But it does take time. It does take effort. I will see you tomorrow on day number 33. Alright? Thanks.